is Vinod Karup. I'm a developer at a great place called Cactus over in the US, and I'm very honored to be here to talk to you today about a talk that I titled Reaching Beyond the Web. The reason I chose that is because I've generally been a web developer up until this really cool project that came into our lap, and I'm going to talk to you about that project and explain to you my epiphany that I came to during this project, which is that the web is probably not the ultimate. There are other things that we should look at if we really want to have our applications be accessible to everybody. So I really have just two take-home points. Number one, I want you to have an answer to the question, why should we build SMS apps, where SMS stands for short message service or text messaging. I guess I have one question for the audience. How many of you have built an SMS app, so some kind of application that responds to a text message and does something with it? Good. So it looks like about half the audience. So you're all more experienced than I was a year ago today. And I'm glad I learned this experience. So I want you to have a good answer for that question. Number two, I want to talk to you about the tool that we used to build this application, which is called Rapid SMS. It's a pretty complex tool, but you don't need all that complexity to use it. And so I want to kind of show you in just 5 minutes how to build a Rapid SMS application. My outline of the talk is going to be talk about this project, which I've kind of referenced briefly, but basically it's called the Libyan SMS Voter Registration Project. If you all went to the first talk of the conference yesterday by Peter, this is kind of a prequel to that talk. So he talked about tallying up the votes. This is how we got all those people to be able to vote in the first place. And like I said, secondly, I'll spend about 5 minutes at the end just talking about an introduction to Rapid SMS. As you probably know, Libya has been through quite a bit of turmoil over the past 5 years. In 2011, Gaddafi was overthrown, and he had been a dictator for many decades in Libya. Since that time, they've taken their first kind of fledgling steps towards democracy, and one of those important steps, obviously, is a vote. So they had to have a voter registration process. The answer is not complete yet. We don't have a good end story yet. I would like to have a happy ending to this, but there are still, as you know, a lot of problems in Libya. But we're hoping that the steps that they've taken, which I think have been very good steps, will continue to a working democracy. So in 2012, the government of Libya basically mandated that they build an SMS voter registration system. And as you can imagine, if you had a dictator who was overthrown and you wanted to start a democracy, you have to find some way to vote, for people to vote. That's got to be a first step. So this is kind of an obvious first step, right? The interesting thing here is that pesky little word number 3, SMS. No government has ever had an SMS voter registration system for their national election. As far as I know, no government's had an electronic voter registration system. So then you have to answer the question, why? Why did they choose SMS? And I think there's 2 different approaches you can take to this question. There's probably the first approach that people in this room probably wouldn't have, I didn't have, but that people around the world might have, is why electronic? Most of us are very familiar with electronics, are probably technology fans, and feel like that's probably a good solution. But there's probably a lot of people that had a question about, why would you even think about an electronic process? My first answer is what's pictured in this slide. In an in-person or paper registration process, we're talking about lines, waiting in lines, bureaucracy, those kinds of things. So that's kind of my first answer, is that the user's time or the user experience is going to be better in an electronic system if it's designed properly. A second thing that we have to think about, especially in a situation like Libya, is protests. So when a dictator is overthrown, there's multiple factions that feel like they should be the ones in power. And so there are protests that in Libya's case, can be quite violent at times. And so having a system where people don't necessarily need to make themselves available to those protests, where they can, in the safety of their own home, make these decisions, that's a win for the citizens. Finally, expense is a big issue. Having the staff to staff all these stations, having all the materials is more of an expense with a paper-type system. All of these, I think, are minor compared to the last one, which is access. This is a map of Libya where up in the west, you can see Tripoli, up in the east, you can see Benghazi. Those are the two darkened areas. This is a population density map. So in those two areas, those darkest areas represent 1,000 or more people per square kilometer. Whereas in the bulk of Libya, all the yellow areas is 1 to 5 people per square kilometer. So there's a 1,000-fold difference between those two areas. And as you can see, most of Libya is desert, and most of Libya is not very densely populated. If you wanted to have an in-person or paper registration system, you would have to find some way to be able to access all those areas. That would either involve multiple stations throughout sparsely populated areas, or asking people to travel long distances to register. And if you want a system that's going to be accessible to the most people possible, that's not ideal. So I think that relatively well answers the question of why electronic. The question that I had when people told me about this project, being a web developer, is why not the web? Why don't we build a web application that we can deploy, people can log on and register via the web? And so there's some good answers to this question. Number one is expense. So in order to access the web, you might need a fancy computer, a fancy smartphone. The fancy coffee is not necessary, but it's a great image. So, whereas to access SMS, you need a phone like this one, or like the one that you want to feed your kid if it's it's not an expensive thing. The cost of smartphones and laptops has definitely come down, and the difference between these two is probably, the gap is probably narrowing, but still, the expense of having a regular old phone is much, much less than the computer. A second issue, which I think is not as important, but is a consideration, is developer time. On the web, all the things that make the web such an amazing place, the things that I love about the web, are things that you don't have to think about in SMS. So there's no HTML, no JavaScript, no CSS, which makes me really happy. But no fonts, colors, all the things that make the web a cool place, you don't have to worry about. And this gets back to what Peter talked about in his talk yesterday. The less code that you can or need to write, the more simple your application is. And the more simple your application is, the less cost it is in the long run. Another minor issue, again, is users' time. It's very easy to pull out a phone and send a text message. We all know how to do that. Logging onto a computer can be problematic, logging onto websites, especially in areas where not everyone has a computer. This brings back the issue of having to travel to a public place and putting yourself kind of in the same situation where you had a paper registration process. But all of those reasons are minor issues. I think the most important reason is, again, the access issue. This is something that was surprising to me, being kind of a dumb American. I kind of assumed everyone had the internet. I'm going to show you something that Mark Twain calls lies, but these are statistics. I've tried to get them from one place on the web, but I couldn't find one source that had all this information, so these came from different sources, which means that they came from different time periods, so the absolute number is not probably correct. Some of these came from 2012, some from 2013, but the general relative concept is what's important. And what this represents is, for the internet column, it's the number of internet subscribers divided by the total population of the country. So that's 16% in Libya. And the SMS number represents the number of phone subscriptions per person. So there's 165 phone subscriptions per 100 people in Libya. So that is a tenfold difference in the amount of people that have internet access versus SMS access. And just for comparison, some other locations that might be interesting. This is a phenomenon that's seen pretty much throughout the world. The United States is an outlier, but even in the United States, SMS is more prevalent, or at least as prevalent as SMS technology. So I think these kind of solidified, in my mind, the reason for an SMS voter registration process. It's widely accessible, it's user-friendly, and it's inexpensive. And the bottom line, I feel like Libya made a wise choice. It's rare that you'll find me agreeing with politicians, but here I do. So I'd like to talk to you briefly about the project that we were involved in. This is a poster that was in Libya that kind of explains the project in Arabic. So if you understand Arabic, you kind of understand the project. But basically it shows you the short code there, and I'll talk a little bit more about exactly what we built. Briefly want to tell you about the timeline because it was relatively compressed. In 2012 is when Libya made that mandate that we should do this. In September of 2013, Cactus joined the team along with partners including Prakelt. And in December of 2013 is when we launched a tool. So December 1st, registration started. Throughout the month of December, 1 million people registered, and December 31st was the last day of registrations. In February, they finally had their first set of elections based on these registrations. We had another registration period in May where another 500,000 people registered for a total of 1.5 million, and then finally had their big elections in June where 200 people were elected. So what is this application that we built? Basically, we have a short code. HNEC stands for the High National Elections Commission, so they have a short code with the mobile network operators. The user has a 12-digit national ID. Every user, every citizen has this ID number, which is unique. And then every polling code, every polling center has a code, which is a 5-digit number. So all you do is you send your ID, some kind of delimiter like a hash mark, and then the polling center code that you want to vote at, and you send that to our system, and we just respond that either you're registered or that there's an error. That's all our application does. So it's a very simple kind of main, very, very easy process. This doesn't quite show up all there, and I don't want you to look at the details, but this is everything that goes behind that process. At the top, way at the top, you can see a little box that says the message that the user sends to us. Way down here at the bottom, you can say our response message, and in between are all the possible error messages that can happen. And so we had to kind of test and build all those things. So even in a very simple application, things are not always as simple as they look. I just want to briefly kind of run through some of the other features that we built into the system. One is a voter query system, so the voter could send their national ID to our number, and then they would get a response of what their registration status was. That was also built into a web application at libyavotes.ly. Translations are obviously important. None of us at Cactus on the developer team can speak or read Arabic, so everything was built in English. And then we use a standard Django setup. So anyone who's familiar with Django knows that you can run a manage.py command called manage.py, make messages, finds all the strings that you've marked in your application, and compiles them into one plain text file called a PO file. We just send that PO file to the service called Transifex, which is at transifex.com, and we get an interface that looks like this, where all the English messages are on the left side, and then the translator comes by and puts the Arabic ones on the right side. We didn't get to this system right away. It took us a little while, and we used things like Google Docs and things that didn't quite work, but this really did seem to work in the end. Translations end up being easy at the end. Encodings generally are very easy in Python. They're super easy in Python 3, but we use Python 2 for this project. But even Python 2, as long as you know what you're dealing with and when you're crossing boundaries, it's very easy to take care of encodings. It's not at all easy when you're communicating with mobile network operators. That's what MNOs stand for. We used Vumi as our backend to connect to the phone networks, and Prakelt took care of that for us. Thank God, because that was certainly the hardest part of this application. And so I had a conversation with a couple of the Prakelt folk yesterday, and I can't remember who said what, but one said, I think at this point we've seen pretty much every encoding you could possibly see from an MNO. And the other person said, no, we've missed one, and that's a standards, one that follows the standards. So again, we thank Prakelt for that. We built a reporting system. So on the day of election, there's, like I said, one center in Tripoli, and there's 1,600 centers throughout Libya. So they want to do a couple things. One is to see how voting is going, to see the numbers of people that are coming in and voting. And number two, they want to do this thing called parallel voting tabulation, which is a election geek kind of thing that I don't quite understand, but it's basically the idea that if you're running an election and you count the votes, you want to have some other way of cross-checking those votes. And so what we did is built a system where, like I said, it wouldn't be feasible if we're just using voice, but with a text message, you can just have staff send in a 5-digit short code. That's the code of the center they're at. Period, and those were periods 1 through 4, just representing different periods throughout the day. And then the third number is the number of people who have shown up to vote. And then at the end of the day, you can compare those numbers to the number of ballots you actually have and make sure that someone's not sneaking ballots in or changing numbers by adding votes to the system. So this is something that was pretty easy to build once you already have all this information in your system. The other thing that this allowed us to do was to display an interface that showed all the different centers, which ones had reported and which ones were missing reports, which would allow the people in Tripoli to call those centers and make sure that they got reports from them. We built a few, or team members built a few analytics things, including fraud monitoring, to make sure that one phone number wasn't making many registrations. We built status reports, including something that looks like this. This was publicly available on the web, currently it still is, at data.libyavotes.ly. It shows the number of registrations that happened during the month of December, starting off the screen at December 1st, and then continuing until the last day of registrations on December 31st. And so this was a very popular tool for the people in Libya to kind of see how things were going. And is like everyone, you can tell that everyone wants to register on the last day. What was interesting is during the first election, they had an in-person registration period as well. So people could go into the polling center and say, I'm having trouble doing this SMS thing, can you help me? During the second election, they decided not to have that. And instead, what we built was a help desk application where staff members in Tripoli would man a phone, and then when the phone call would come in, they could just step by step go through our process and say, ask the citizen this question, check their ID, and submit, and then if it's valid or invalid, it would tell them exactly what to do. And so we built a system that kind of allowed them perhaps to completely eliminate in-person registration. Because we had everyone's phone number in our system, we could do cool things like remind voters to vote. So on the day of the day and day prior to elections, we sent off 1.5 million text messages to all the voters, reminding them to vote. And I learned yesterday that was also perhaps legal, based on the MNO's idea of what was legal. But finally, there were also registration center changes. So unfortunately, there, like I say, were protests. A few registration centers were bombed prior to elections, and so changes had to be made where we could send that information to the voter saying that this registration center is closed and you've been moved to this other one. I'm going to just briefly talk about deployment because I think this is a pretty awesome system that we built. This is, I still don't understand all the pieces of this. The part that we built is that little blue box, and then all of our partners helped build the rest of it. And for our piece, we had 3 application servers, a database server. There were multiple analytics servers. I think there were a total of somewhere between 15 and 20 virtual machines that ran the system. We used something called Fabric, which we've definitely heard about at this conference, but it's basically a remote execution tool that allows you to easily deal with multiple servers and across SSH. We use Salt as our deployment tool, which is, again, a declarative way of saying what you want your server to look like and that you want App 1 to look just like App 2, and that made it easy to do these things. And we use something called our Cactus Django project template, which has all of these Salt scripts and Fabric scripts together in one open source place. This is what we kind of feel as best practices for a Django project, and so I encourage you to take a look at it and see what you think. Testing is a huge part of this. We don't want this to go wrong, obviously. We built automated tests that, if you went back to that flow chart I showed way back when about all the error messages, we built automated tests that in Python sent those error messages and made sure that we sent the right response back. We had over 90% code coverage. We felt very comfortable at the end that we could change things without breaking something else in the other part of the code, which is very important. But we found pretty early that automated tests are not enough. And so the staff at HNEC was instrumental in testing this themselves. And so they used their own phones, and they found out things that we never expected. So at one point during our process, we decided that in order to ease troubleshooting, let's add a little message number to each excuse me, each possible message that we send out. And so that way, if we send out a message and the staff member looks at it, they can tell us exactly which message they got, and then we can look in our database and see, is that the right message, and how did we get there? And so we had a very innocent message looking like this, said blah, 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 blah in Arabic, and then message 58, and sent this out to someone's phone. And I don't have the actual image, but I have this, which you can kind of see here, turned into this. So here we are, a very serious voter registration system. We're sending out googly eye smiley faces to people, which is something that we couldn't have guessed and would happen in our automated testing. So, and we fixed this in a very ugly way by initially trying to add a Unicode character, which is a zero width, non-breaking space, hoping that it would be a space between the two characters. But this phone, and probably many other phones, just shows that old Unicode box. So now we put an 8 space parenthesis. So that is basically the gist of the project. I just want to briefly talk in about 5 minutes about Rapid SMS. It's a tool that was developed by UNICEF in 2007. It's been well tested since that time. It's free and open source under BSD license. Those are the links that you can go to find out much more about it and to submit code issues or code changes. It's very easy to install. It's based on Django. So basically, you start your Django project, and then you add RapidSMS as a requirement. Just pip install RapidSMS. And then this is, again, a very complicated diagram that I don't want you to look at. Unfortunately, got cut off at the edges, but there was a phone over on that side and a computer on this side. And so basically, messages come in via the phone system. The two important pieces are this thing, which is called a backend, and this thing, which is called an application. If you have those two things, the rest of it kind of falls into place, and there are sane defaults for everything else. But you basically have to find some way to set up a backend and then create an application, and that's it. That's all you need to do to install RapidSMS and get it working. RapidSMS backends, like I said, are kind of an important part. Usually the hardest part of building a RapidSMS or an SMS application is figuring out how you're going to connect to the phone system. An easy way, especially in testing, is something called Twilio, which I'm not sure if, I think they are present in South Africa as well. It's basically, they have a bunch of phone numbers. You rent a phone number from them. Any messages that come into that phone number get posted, HTTP posted to your application, and then you can deal with it. And then when you send out messages, you post to their URL, and then they send that out by the phone system. So it's a great way to at least do testing, but you can build applications on that as well. You can use an Android phone as a very cheap USB modem, not high performance, but it can get things working. You can get GSM modems, and finally, if you need highly available and highly scalable solutions, you can talk about things like Vumi. And there are many others that are available as well. In order to set up RapidSMS, there's basically two settings you need. So there's, in your Django settings, you define something called installed backends. You give that backend a name. Libiana was one of the mobile network operators that we used. Every backend needs an engine. An engine is basically just a Python class in your application. And this one is built into RapidSMS, so this is all the coding that you need to do that. And then Vumi specifically needs a URL that tells RapidSMS where Vumi is located. In our situation, it's in a different machine, but it could be on the same machine, and that's just a URL that Vumi will accept messages at. So that's for sending messages out of your system. If you want to get messages into your system, then you need a Django URL. So you just set up a URL. We call this one backend Vumi Libiana. Point that to a view, and this one is built into RapidSMS, and then give that backend a name which links to the installed backend name up there. With those two settings, you would have a working backend. The second step is to build an application, and this is just what you do with the information that comes in, and it's just Python. So you import from AppBase, and you just define a handle method that accepts a message, and then that message has an attribute called text, and you can just look at that text and say, if I receive the message ping, then I'm going to respond pong, and then you return true, which tells the system that you're done handling this message. So that's the simplest possible RapidSMS application. there's a lot more complexity to it that's possible. This is all the stuff that's built into Rapid SMS. You can have multiple applications. So like I showed you one application, all the applications in your Django installed apps would get searched. And then what it does, what Rapid SMS does, is it goes through the filter phase of app 1, the filter phase of app 2, the filter phase of app 3, the parse of app 1, parse of app 2, like that. And so there's a ton of complexity that you couldn't build into the system. I think the application that we built for Libya was pretty complex, and we didn't use any of this. So I think it's kind of over-engineered, but it's nice to know that it's there if you need to build that kind of a complex application. For Libya, this is one instance where it was very useful to have those different phases. We wanted to parse every text message that came in and kind of split it into those numbers. Like I showed you before, the user would send in their 12-digit NID, a 5-digit code, and these would be separated. The requirement was that it could be separated by anything. It could be separated by a hash, a space, an asterisk, a letter. And so for those of you that were at Adriana's talk earlier, you can understand this now because we use a simple regular expression to look for anything that was a non-digit. And so we just make sure if this is a non-digit, then we're going to split the message based on that non-digit and then find just things that are numbers in that and set that to message.numberList. From then on, every application downstream has that number list in it. And so they don't have to reparse. And so it makes it somewhat easy to kind of separate your phases into a filter phase, where you clean up the data and then you handle it in some way. There are some other rapid SMS concepts that are less important. There's a router. The default router is a blocking router, but you can use a celery router to get async processing. There are things that are, again, I could talk about these with you in detail, but they're just things that make things a little bit easier to use: connections, contacts, address book, a way to do web testing over the through the web interface rather than using a phone. And like I say, since it's open source, there's a lot of third-party modules that are freely available that would often do what you need to do. I just want to mention a couple cool Rapid SMS projects. Like Simon mentioned, Rapid SMS is often used for non-governmental organizations doing really cool things. So these are two of the projects that Cactus has built over the past few years. I had nothing to do with them. They were built before I came aboard. But one is a 1,000 Days project in Rwanda, where it was a project aimed at decreasing child mortality during the critical 1,000 days after birth. And there was another one in Project Mwana, which provided HIV test results to infants and their caregivers within hours or minutes after the test was done, rather than by courier, which would be sometimes months later. And so there's a ton of other cool projects have been done on Rapid SMS, and it's a lot of things to look at to see what's been done before. So finally, coming to the conclusion, I just want to remind you of the take-home points. Number one is that you want to always think about, is access important to your project? If access is important to your project, then SMS is important to your project. We can't just rely on the web to reach everyone that we need to reach. It's very easy to add SMS to a web application. In our system, we started with an SMS application and added web functionality later, but even if your predominant audience is web-based, it's easy to add SMS to it to get even broader reach to people. The other take-home point is that Rapid SMS is very easy to set up. I hope I've just demonstrated that. It's also very flexible and scalable, so that if you do need more complexity, it's very easy to get that later. And I do want to emphasize that Rapid SMS is what I know. It's not the only option, obviously, but I think point one trumps point two, that if you really think you want to access more people, then find some way to build SMS into your system. Finally, when you talk about a project like this, it makes it feel like I had a lot to do with this. I was a very minor part, and so I want to make sure I thank all the other people that were involved, including multiple companies and multiple people that I hopefully didn't miss too many of. But I thank all those people. I thank the organizers here for having me come talk about this. It's been a great experience for me coming to Africa for my first time. My son's head is cut off there, but those are my three superheroes. The most important one is missing their mom. She's not in that picture. But I would love to answer any questions that y'all have. That's my contact information if I can answer any questions after the talk. But thank you very much.
We do have a few minutes for questions. So if you have a question, please stick up your hand and I'll get the mic to you.
So, Vino, did you have people that would completely, how often was it people didn't understand the instructions at all and would send you text in a human language? Because all the SMS products I've worked with, that's happened all the time.
Yeah, that's a good question. I know we did some analysis of errors, and surprisingly, the amount of errors coming from the general public was less than the amount of errors coming from staff members doing our reporting functions. And I think the reason for that, the staff messages that were sent were more complex. Obviously, there were 3 or 4 numbers. You can easily mix up 1 or 2 of them. But we had relatively few errors, meaning less than 5% of coming from citizens itself.
Thank you.
Hi. So how extensive was your fraud management, as in to check maybe against the national birth and death records to ensure that those IDs are actually allocated and they're actually people who are alive and that type of thing?
That's a great question. So I have to admit that I don't have the full knowledge of the entire fraud monitoring system that was built and that was taken care of. For that specific piece, we use something called a civil registry authority. So there's an organization within Libya that their job is to manage the civil registry. And that's a database that they would kind of dump and we would load into our Postgres database whenever they dumped it to us. I think it was monthly or something. Yeah, it varied whenever we could kind of twist their thumbs to do it. But so part of that big ugly flowchart I showed was we would send an API call to that database and make sure that the ID was a valid ID and that the patient, that the citizen was more than 18 years old, which is a requirement. Thanks.
Oh, let me get a microphone to the back. That one might have run out of battery. It was on 1 bar.
Yeah, there it is. How did you make sure that on the day of the election that the whole system will scale properly? For example, first of all on your application, but also on the mobile operator side for the SMSs. Because I mean, if the whole country is going to SMS on one single day, things could, fall over.
Excellent question. I may have not explained things in enough depth. There are 2 different processes. One is the voter registration process. That was a month long. So that went from December 1st to December 31st. So there was not one day that everyone was SMSing. The voting day was, but the only people that were SMSing on the voting day were staff members. People were actually physically going in and doing old-fashioned paper ballots. But in regards to the first question, we were very concerned about that, and so we used a tool called Apache JMeter to test and make sure that we could get the load that we wanted, which was somewhere around 100 messages per second. We never, fortunately, hit that number in production, but we were ready for that. Yeah.
Any more questions?
Did you have a way to ensure that people didn't register on fake ID numbers?
So the ID numbers, we did validate that they were in the civil registry. There were parts of the fraud monitoring system, like I said, I don't understand exactly what was done for that, but part of it was making sure that a certain number of registration, more than a certain number, could not come from the same phone number. And initially you'd think, why would more than one? If everyone's got a phone, why don't they all just use their own number? But in certain villages and towns, more than like 10 or 11 people would sometimes use the same phone, and that was actually not felt to be fraud. That was actually people really trying to register. So there was some kind of strain between minimizing fraud and really allowing accessibility to everybody. But for the ID itself, we did check that number.
I have a question.
Sure.
As a sort of follow-on to your answer. have you looked at the data you got to put out statistics on, say, how common it is for 4 people to be using the same phone?
We did. I think so. Elliot, who's I should have mentioned him more specifically. That guy in the center who's actually wearing the exact same T-shirt today has worked for at least 3 of these organizations, I believe. Currently working for Cactus, but he's kind of been the person in charge of this whole project. I think you did some script specifically to look at that, right?
You should get a microphone if you can answer.
Yeah, I mean, in terms of phones, there were about 600,000 of the registrations of the 1.2 million, 5 million now, that were from, basically one person, one phone, or one ID, one phone. And everything else, basically the vast majority of the rest were between 2 and like 10 or 11 NIDs, or national IDs. So the idea there was, by and large, they would be things where you could trace back the number of IDs to a family record. So basically, it's a father or a mother registering everyone in their family, or more often than not, the first registration you'd get is someone that's 19, 20, and is helping their parents with registration.
I was just wondering how the 1.5 million figure compares with the number of eligible voters in the country. Do you know? Because that would certainly tell whether the SMS system does succeed in terms of accessibility.
Good question. I didn't bring it up because I don't know. I know the numbers. So there's 6 million people in Libya. Approximately 70% of them are adults, so that'd be about 4 million. So that's 1.5 million out of 4 million. So what I don't know is if that's a good number. If you compare it to the US, that's pretty good. If you compare it to other countries, it's not. So yeah, it's a good question. I think a lot of people are asking that same question.
Cool. Any last questions? We probably have time for one more if there is one.
Did you have a lot of privacy concerns in terms of people connecting their phone numbers with ID numbers and locations, especially in kind of a war-torn country kind of thing?
Again, a very good question. I don't know. We didn't, as far as I know, we didn't have any vocal concerns like that. There may have been a silent concern in why those other 2 million people didn't register. That may have been a concern, but we didn't hear anything like that.
Cool. Thank you again, Vinod.
Cool.